So this course is what we call analytical chemistry. And if we're going to look at this, we could say this is a continuation of your Chem 32. So everybody took Chem 32 already?
Yes po.
Okay. Hindi ko magamit yung ano to. Wait lang ha. Hindi ko magamit yung pad ko eh. I-on ko lang. Okay, there you go. Tapos i-charge. Kasi wala na siyang. Okay. Hindi pa to dito. Kasi na, technical problem. Okay. This analytical chemistry that we have started during Chem 32, we use it to understand unknown or complex phenomena through chemical analysis. If we're going to ask what analytical chemistry is, that's what analytical chemists do. Okay, it usually answer the question, what is present and how much is present. So when you do analytical chemistry, you identify, separate, and measure specific chemical substances or processes. So it's just either a qualitative analysis or a quantitative analysis. So the quali answer the question what, and the quantitative answer the question how much. And typically, you should do qualitative analysis before quantitative analysis. Why? Anyone? Why do you have to do the quali first before the quanti? Yes, Gerard.
Sir, ayun. Hello po. Ayun. Ano po sir, because before po natin malaman yung concentration or yung amount ng analyte sa isang sample, need po nating malaman is if present pa yung sample na yun. Kaya po need po natin ng qualitative muna bago yung quantitative.
Okay. Because in doing so, you're not going to waste time, the reagent that you're going to use. If it's not present in the sample, in the first place, why do quantitative? And usually quantitative are more expensive than qualitative. Okay, so if we're going to look at the qualitative instrumental analysis, that's the one that measures the property. It just indicates the presence of analyte in matrix. So this is answered by either what? Yes or no. Okay. Now, quantitative instrumental analysis is that magnitude of measured property that is proportional to concentration of analyte in matrix. What is this analysis? Is this quali or quanti? Anyone? Lakihan ko yung ano ha, para makita nyo. So what is this? Is this a quantitative analysis or a qualitative analysis? Okay, so this is what? COVID test. Okay, so COVID test just answered the question, do you have COVID or not? Okay, so this is an example of what we call qualitative analysis. Another test that has what we call similar to this is yung tinatawag nating pregnancy test. That is also a qualitative analysis. Okay? Test kit photo dito sa amin. We have a lot. Okay? Sabihin nyo na lang sana all. Okay. Okay. Now, how are you going to do quantitative analysis? Let's say if you want to know how much virus that you have. So meron kang testing na pwede mong gawin. And usually you do it after you get the vaccine to determine yung viral load mo. Okay? How about the sugar meter? What it is, a quali or quantitative analysis? Is it a qualitative or a quantitative device? Yung sugar meter. Malayo dito yung sugar meter ko eh. Okay? Since you see the number there, that is a quantitative device or quantitative analysis. It gives you the number that you have, 120, or if you're diabetic, around 170, like me, around 180. Okay? So that's the difference. Now, we can, what we could divide this method, analytical method, either to the so-called classical or yung tinatawag nating, other terms sa classical method. Yung mga wet lab-based method. Okay? Yes. Yes.
Wet chemical method daw po.
Okay, yep. Wet lab method. Okay? So there's two main methods there. One that looks at the mass, that's gravimetry. And the other one that looks at the volume, which is volumetry. Or the classic titrimetry or titration. So here we have what? Isolation, okay, where you either you do precipitation, extraction, or distillation. And then you can go you can determine the color, the smell, the taste, the boiling point, the melting point, and the solubility. So you have to do it in a wet lab. And usually, typically, we separate the wet lab from the instrumental lab. If it's instrument, we don't do wet lab there. Okay? Because we don't want contamination in our instrument. And if you have a classical analytical method, you cannot do it at home. So do not try this at home, nor in the instrumental lab. Okay? So whenever you have an instrument, now my worry is, I don't know if you have experience using instrument kasi lahat kayo, most likely, pandemic. So I don't know if you're doing 140. That is a lab. Okay. And then this one, I don't think 111 meron siyang lab na gagamit ng instrument and maybe calorimeter. Okay. So whenever you have an instrument, you just try to look at a particular chemical system there. So the way that you have there, okay, you're trying to put or apply a stimulus in the form of light, heat, current, voltage, or maybe other chemicals to your analyte. So what happened? Okay, if there is some sort of a reaction, so when you expose it to light, it induces reaction in the chemical system where you analyze it, it can what we call put out signal. Okay, so the input that you have there is in the form of the transducer. So that's where, okay, you're going to have a system that is affected when you apply the stimulus. Okay, so once there's some sort of a reaction there, okay, there's going to be a signal that is being generated. So that signal can be amplified or digitized, and then it will be converted to something that you can read. So ano yung something na yun? Pwedeng analog, meron kayo nakitang line, or meron kayo nakikitang number, digital. Okay? So what really happened there, when you do the analysis, you're encoding something Okay, so if there's a signal that is generated, you're going to decode that thing. And typically the signal that you have has a direct or indirect relationship in your target analyte. So that's, we could say, the summary of how instrument work. Okay, so if you're going to look at this instrumental analysis, so you have a chemical system. Okay, so you encode it. Okay, so in that encoding, you can what we call put out some sort of an analytical signal. So maybe in the form of external signal, and then a signal generator. Okay, so as much as possible, you try to convert it into what we call analytical signal. So either you can have a dispersive element, if it's some sort of a metal. Okay, so the signal generator that you have here could be what? A lamp, an AC/DC signal source, or the sample itself. Okay, so sometimes when you put a lamp there, so the matter can interact with light. Okay, so that interaction can generate a signal. Okay, now in the form of this analytical signal, the one that is produced from that interaction, okay, it can either be what? Spectroscopy, electrochemistry, or some other chemical species. Okay, that leads to separation. Okay, so the main thing that you have is you're going to look at something, okay, that when you interact with your analyte, it's going to produce some sort of a signal. Okay, so find something that produces a signal, and that signal, okay, will have some sort of a relationship doon sa target analyte mo. Okay, so when you decode it, you can disperse the analytical signal, which is in terms of selectivity. You can convert it to an electrochemical electrical signal, process the electrical signal, or output the resultant signal. So ano yung mga dispersive element na inaano nyo dyan? So it depends. So if you're looking at the light matter interaction, you have what we call the monochromator. What does the monochromator do? Anyone? First time you ba narinig yan? What does the monochromator do? If you're going to look at the name, mono, which means what? One.
One
So chrome, there is what? Colored.
color.
Okay. So that means when you have a monochromator, you narrow down the wavelength at a particular wavelength that it can absorb your sample. Now, if it's mass spec, it has something to do with the magnetic field. So the magnetic field would separate, okay, your sample in terms of the mass to charge ion. In terms of what we call the column, okay, so the interaction of your mobile phase and what we call stationary phase, so they interact, so the mobile phase is moving, its stationary phase is there. So the interaction that they have there results in this so-called separation. So yan yung mga dispersive element that we have. And we will go on it as we go on each technique. Now, in terms of the signal processor, you have to take into consideration the buffer's input and the output transducer. You can have like an amplification, mga amplifier, the alternate current to direct current converter or conversion, the ADC or DAC, okay, alternate direct current or direct alternate current, and then the current to voltage conversion, your modulation or wave shaping, sometimes this Fourier transform or integration. So yan yung mga signal processor. Okay? So yung input transducer natin that converts your analytical signal into electrical signal, it can be the PMT, okay? Or you can have the CCD. the PDA. What's PDA? Anyone? Hindi yan yung public display of affection. Okay, what's the PDA here? Any wild guess? That's your photodiode array. Okay, CC discharge coupled device. So usually they use it in the conversion of photons into electrons. Okay, or if you're looking at the potential itself, you can have the electrons, like electrode, like the pH meter or the glucose meter. Now, the output transducer that you have there, usually you convert your electrical signal into something that you understand, human understandable signal. So usually you have a computer. It also does much of the signal processing. Dati computer, ngayon, kahit sa cellphone, pwede mo nang gamitin output transducer. Okay? So, if you're going to look at this, you can look at the so-called domain. So there are what we call the electrical domain and the non-electrical domain. And in this different domain, yung physical and what we call chemical domain, okay, non-electrical yan. And the scale position and the number. Now, in the electrical domain that we have here, it can be an analog, so you can have the current, the voltage, or the charge. Okay. So if you're going to look at this, we could say this is what? Voltammetry, potentiometry, and coulometry. When I say coulometry, the coulomb. Coulometry. Okay. Now, in terms of time domain, in electrical domain, you have the frequency. You have the pulse width, the phase. Okay. And then in terms of a digital, it can be a parallel, a serial, or a count. So that's the nature of your data, the domain that they have. Okay. Now, most of the instrumental are what? Anyone? What domain the instruments usually for?
Physical and chemical.
Okay. So if you're going to look at most of the instrument, they are in the electrical domain. Yung physical and chemical domain, yan yung makikita mo if there's a color change. That's it. If there's what we call the increase in temperature by just feeling it. Okay? So walang electrical signal na nag-aid sa'yo para makita yung changes. So which is better? The use of the eye or the use of a spectrometer? The spectrometer is more sensitive than an eye. So maybe if you see it using your naked eye, you see that there's no color change. But if you're going to use a spectrometer, you will see that there's some signal that is generated there. So that's what it means by the difference between electrical domain and non-electrical domain. Okay. So if we're going to look one example, spectrophotometry, and we will discuss about that. So typically, this is the block diagram. So you have to know how to sketch the block diagram of instrument here in this course. Okay. So in a spectrometer, it has something to do with what? Light interacting with matter, and their matter is your sample, your where your analyte can be found. So if you have a light here, so the first thing that you have, there's a light source. Now, usually a light source are what? Broadband. It has a wide wavelength. So if you want to look at, let's say, a certain color, I want to look at what we call orange. So you need a monochromator to make sure that only light at that certain wavelength will pass through the sample. And then there's the light that gets in and the light that gets out. So the difference on that is what? The light that is absorbed. Okay, so usually you have a sample there that you put in a cuvette. So you have a photoresistor here, so that will convert your analytical signal, okay? And the amplifier would make the signal a little bit higher, okay? Maybe converting it to electrical signal and then to something that you can understand, which is what we call the output reader. So if you're going to look at the stimulus, you use what? The monochromatic light energy. So usually you have a lamp, tungsten lamp. Okay. But right now, if you want a monochromatic light, you use what we call the laser. It has a higher intensity compared to just the lamp. And it has a narrow wavelength. So if you're going to look at the analytical response, just the absorption, the attenuated light beam. So the transducer that you have there, that's the photocell or the photodiode. And the data that you get is the electrical current that you can see in a data processor, that's current meter. So you have either a meter scale, an LED, or a computer. I'm not sure, but I think if they preserve the old instrument there, you can still see there. During that time, whenever we have this old instrument that is already broken or old, we usually open it to let the students see the parts of the instrument. Okay? So this is just one of the instruments. You're going to learn a lot like this one. And they said, the more instrument, the better. Do you agree on that? What is the advantage if you have a multi instrument compared to just one instrument? Let's say if you ended up in a forensic science or a forensic lab. So ano kapag meron ka lang doon UVBs? So compare it with the one that has an IR, a UVBs, and let's say an LCMS. Which one is better? Lab A or Lab B?
Lab B po.
Lab B. Okay? But what's the problem of Lab B in comparison to Lab A? They need more what? Anong kailangan ng Lab B? They need lot of
Money po.
money, money, money. What's so funny? You need a lot of money to do that. Okay? And if you're going to look at this, if you're asked what do you think is the best instrument, is there an answer to that question? If you're given what we call a wish, you buy an instrument that you think you can use to analyze all stuff. Is there such instrument? What is your answer? The answer would be maybe. Okay, it depends on what's the purpose or to what chemical you want to use it. Okay. Now, some chemicals are better analyzed by a certain method compared to another method. So for instance, if you want to use HPLC, what's the primary requirement of your sample to be analyzed in HPLC? Anyone? Ano yung characteristic ng sample mo? Dapat ano siya? If it's HPLC. So HPLC is high performance liquid chromatography. So the main requirements that you have that if it can be dissolved in a solvent, then most likely you can analyze it in LC. Okay. So if it's soluble in a solvent, then it is can be analyzed by HPLC. Now, how about the GC? Anong difference ng dalawa? Now, GC, it has to be what? That it has to be soluble, yes, but what's the characteristic of the solvent? The solvent should be what? At least volatile or volatile. Kung gaseous ang solvent, mahirap i-dissolve yung solvent. But if you can put it, let's say, in an organic solvent, you can apply it with GC. GC is not applicable for water soluble thing. So if we're going to look at the chemical and the physical methods, okay, in the instrument, employed in the instrumental. So I think this is a summary. You can find similar to this in the module. Okay. Now, you have the emission of the radiation. So I have experience here in fluorescence. You have the absorption of the radiation. So I have experience in the UVBs, in the IR. Okay. Scattering of radiation, I have experience in Raman. Okay. Refraction, refractometry, we have an instrument of that, but I have never used it. Then you have diffraction of radiation. I have experience with X-ray diffraction. Okay. Rotation of radiation, I have experience using polarimetry and circular dichroism. So circular dichroism, if you're taking biochemistry, you know the different conformation there. Alam niyo ba yung different conformation ng biomolecules? Either it was what? Alpha helix, beta sheet, coil, random coil. So you can analyze it using CD, circular dichroism. So electric potential, I use potentiometry. Electric charge, since I'm teaching instrumental analysis, that's the only time I use colorimetry. Electrical current, that's my research when I was there in the Philippines, developing sensors to analyze heavy metals. Okay. And then electrical resistance, conductometry, the mass. So you use your QCM. You weigh it in the microbalance. Okay. Mass spectrometry, I use it. Kinetic methods. So I think if you have 112.1, most of the experiment there is what we call kinetic methods, the clock reaction. And you have thermal characteristics. So meron dyan tinatawag na TGA at DSC and DTA. I have experience using that. We try to determine if there's a difference between a rabbit brain of the dog compared to the normal brain, and we see some difference there. And last but not least, the radioactivity, which I also have experience. I use what we call the liquid scintillation counter. So you use here radioactive stuff. So what experience I use it is we have a radio-labeled antibiotics, and we try to determine when we let the animal ingest it, what happened, okay, to the antibiotic. So these are just some methods, and we're going to learn some of them, at least the basic principle. And I'll try to see if I can show you some of the what we call video that we have in the lab. I have two laboratories here, one that I'm the one in charge and the other one where I am one of the assistant. So the one where I am the assistant, it has high-end laboratory. Okay, so if you're going to look or you're going to determine what analytical method you're going to use, you have to look at some of the so-called figure of merit. Okay, so hindi agad na anuhin mo, pwede mong gamitin lahat. You have to look at the so-called figure of merit. Okay, so usually the figure of merit will some way a performance or rating or of the efficiency of a given instrument, device, or what we call material. So ang tinitingnan mo doon sa figure of merit ay yung different na ito. Precision. So precision is usually standard deviation. Okay, if you square the standard deviation, you have the coefficient of variation. And then you have to look at the bias, yung tinatawag na systematic error. Is it absolute or relative? And then sensitivity. I think next meeting, we will do more calculation. Yung detection limit. You're just wasting time if the amount of your analyte is way below your detection limit. What does it mean? It's always ND. What is ND? When you have what we call in a publication that has ND, what does it mean? Anyone? ND is not detected. So usually you don't detect it because the analyte that you have is lower than the detection limit of the method that you're using. And then you have the so-called concentration, what we call range, the LOQ and the LOL. And then you have what we call selectivity. There's a lot of this being mentioned on some module. Okay. And the thing that you need to consider is this one. Speed. Okay. Are you watching CSI? Nanonood ba kayo ng CSI? Anong problema dun sa CSI? Ang problema sa CSI yung speed, right? Yung pag nilagay nila yung sample doon sa instrument, makukuha agad nila yung result. But that's not the truth. Okay? It takes a while for you to determine or to complete that type of analysis. Okay? So, even then they said that this is what? It's what we call time cheat. Okay? And then, another thing that you need to consider is inconvenience. When you say is it convenience, gaano kalayo yung instrument mo? Or you prepare to do a bench top instrument or the one that we call portable? Karamihan kasi ngayon portable na eh. Okay. Yeah, the thing that they have there, I mean, yung himala meron lahat, is they didn't even show the most important thing in chemical analysis, which is sample prep. Hindi naman yung pag in-inject mo yung sample, makukuha mo na eh. Kailangan tanggalin mo muna. Okay? Kasi yung matrix doon, makaka-affect doon sa analyte nyo. Okay? Now, you need some skills that you need to develop. Marunong ba kayo mag-weigh? Have you weighed a certain chemical already sa setup ninyo sa UPLB?
Yes po.
Oh, meron. Well, that's good. Okay. Okay. Because I think that's one skill that I have learned is at least this so-called weighing, especially in the milligram level. A lot of students of mine, they always call me, Professor, I cannot weigh 3 milligrams. And they are amazed that I put this Eppendorf tube, and then I said, how did you do that? And then I said, oh, maybe experience. Okay. Because they have to prepare less than 3 milligrams, or else in an Eppendorf tube, or else it will not dissolve, because higher than that, okay, the reagent will not dissolve. This one that we do in antioxidant assay. And then you have to do at cost and availability of equipment. And that's the main problem there in the Philippines. In the Philippines, you have a lot of people, but you don't have any instrument. Here in the US, we have a lot of instrument, but we don't have any people. That's the reason why I go to that other lab. Okay. The number of instrument there is much more compared to the number of people. And when I go there, there's 3 to 4 instruments that are running at the same time. And all I need to do is put my sample in the cuvette and then jump from one instrument to another in analyzing. And you have to take into consideration yung per sample cost. Some analysis like LCMS is so expensive. Some analysis like heavy metals is so expensive. When I went there last summer, I'm supposed to look at the heavy metals in Marinduque, having been the victim of an environmental catastrophe, okay, the Markaper. But we cannot do it because it's so expensive, the AAS. Okay, so these are the things that you need to consider whenever you have this method choice. And I'm hoping by the end of the semester, you'll be able to answer question, what's the best method if you want to analyze a certain chemical? Okay, so the figure of merits for precision and analytical methods, you have this one. I think you have this already in 32, right? Meron na kayo sa 32 nito, yung totoo. Remember, you're
Yes
going to
po,
have,
sir.
you're going to have a board exam. So ito yung mga tatanong doon sa board exam. Okay?
Pero ang nangyari lang po kasi, sir, puro po kasi calculate. So yung standard deviation is yung diretso na lang po input yung mga data, tapos titingnan na lang po sa calculator ko ano yung standard.
Buti nga,
So
calculator
medyo
kayo
nalimot
eh.
na po yung mano-man.
Buti nga, calculator kayo. Kami, Excel na kami dito eh. Ita-type lang namin, tapos magko-command. Yun na yun eh. But you have to do it in the calculator because you cannot use Excel in your board exam. Okay? Ang style lang yun, during that time, tinuturo ko pa rin sa mga estudyante ko dito, i-input nila yung data. Maganda na ngayong calculator ngayon. And then from that, they can get the RSV, the coefficient of variance, standard deviation. Pero tinuturo ko yun, pagtapos na yung exam, okay, para i-ano nila yung mano-mano. And then this is what we call the limit of quantitation, and this is what we call LOL, the upper limit. If you're going to look at the LOL that you have, limit of linearity. So sometimes, hindi linear yung calibration curve mo, so you have to just take into consideration yung what we call linear sila. Okay? So the main topic that I have today is yung tinatawag na signals and noise. Because I think this may come up in your what we call board exam. Okay? So if you're going to look into consideration, when you do analysis, sabi nila itong analytical data may dalawang component. Okay? So yung dalawang component na yun eh yung signal tsaka ang noise. Pero doon sa bigay ng analytical data, may isa pang component na dapat mong i-take into consideration. Okay? At yun yung tawag nating yung chemical information. O yung sample mo. Kasi kung wala yung sample mo, walang signal na ma-generate, walang noise na makikita. But in some book, they said all analytical data, usually they have this what we call signal, tsaka yung noise. So if we're going to look, all instrument measurements involve a signal. Unfortunately, all signals have noise present. And in some, the noise is large, but sometimes it's so small you can't see it. The problem with the noise is affect the accuracy and precision of your data, of your signal. Okay? Sometimes the noise limits the detectability of every instrumental method. So present yan lagi yung noise na yan. Okay? And it cannot be completely removed. That's the problem with this noise. So at least the thing that we do whenever we use an instrument, we have to understand ano yung contributions ng noise at paano natin ito ma-minimize. Okay? So maybe the first thing that we can look is, ano ba yung noise? So if you're going to look at the signal that we have here from current, so ito yung makikita mo na may noise. See that? That's noise. But if you want to remove the noise, maybe you can apply some hardware and or software methods on that. So here, you could see, wala na yung noise. Mas maganda na yung kanyang signal. Okay? Now, you might ask, saan ba nanggagaling yung signal? Usually, nanggagaling ang signal saan? Anyone? Doon sa analyte na tinatarget mo. Right? The signal would usually be one that contains information about the analyte that you are trying to determine. Okay? And usually, yung signal, it can be what? Proportional or directly proportional doon sa concentration or mass ng analyte. Right? So for instance, you look at the light-matter interaction. So kapag absorbance yung tinitingin mo, mas maraming analyte, mas mataas yung absorbance. Okay? Are you familiar with this? Anong tawag dyan? I think you have this in 32. Okay, that's the Beer-Lumber law or the Beer's law. And as you could see here, the absorbance is proportional to the concentration. This is specific to a certain wave, what we call chemical. And this is usually what, 1 centimeter. Now, ano pa yung pwede nating ipakita dito? Are you familiar with the Nernst equation? You look at the potential that you have there in a given thing. So yan yung pwede natin sabihin source ng signal or principle. And as you're going to look at this as much as possible, noise is often constant and independent of the signal. So when you have noise, what do you see there? Okay. You see there's some sort of what we call the extraneous information. Part of the data that contains is what we call extraneous information. Kita mo yan. Ang pangit tingnan. Okay? So how do you minimize noise? How do you improve the so-called signal-to-noise ratio? Okay, kasi itong signal-to-noise ratio niyan, isa-isang figure of merit. It's a parameter that describes the quality of data. And if you're going to look at the signal-to-noise, usually it's just mean of the signal over the standard deviation. So the higher the mean and the lower the standard deviation, the better is the signal to noise ratio. Okay? Now, paano natin ma-improve tong signal to noise ratio na to? Okay? So there are a lot. So maybe to improve the signal to noise ratio, i-improve mo yan sa taas. You enhance the signal. Another thing is you decrease yung nasa baba. Okay? Or reduce the noise. Kasi itong SN na to, ito yung signal, ito yung noise. Or you modify the instrumental method. So whenever you're using this what we call instrument, the thing that you need to do is you always maximize the signal to noise ratio. Okay? Kasi mas maganda yung results mo. So, try to look at this. Which do you think you're going to be more confident in these two sets of data? Look at the signal to noise here. So low. Hindi mo alam alin dito yung signal, alin dito yung noise. Compared to the one here. So what's the difference between the two? This has what? 10 times better signal to noise ratio compared to that. And if you're going to look at this, this is almost what? In the detection limit. So if you have a signal like this, you don't know which is the true signal and which is noise. But if you are doing it for what we call at a while, makikita mo alin talaga yung signal, alin yung noise. Okay? One way to do it is what we call get a lot of what we call reading or replicates, and after sometimes mai-even out yung mga noise. And what you have there is just the signal. Okay? So, what are these what we call sources of noise that we have? So the first one that we have is this so-called chemical noise. So when we have this chemical noise, this is just the result of chemical or physical properties of the sample. Temperature can play a role there, pressure, humidity. That's the reason why you don't want the wet lab to be together with the instrument lab. You don't want reagents. As much as possible, there's a room for the wet lab and there's a room for what we call an instrument lab. Okay? So chemical noise, fluctuations or uncontrolled variables, degradation, photoreactivity, okay? The temperature and pressure effects, and then we could say you can only minimize it if you know your sample. If your sample is photosensitive, so what does it mean? You have to do the analysis night or at the dark. Some sort of that. Or ilagay, takpan mo lang ng carbon paper, okay na. Okay? So yan yung tinatawag nating chemical noise. So yung isa, since we're dealing with instrumental analysis, we have this so-called instrumental noise. And instrumental noise, these are what we call noise from instrumental components. And it's really inherent in electronic device. Okay, so I try to simplify the definition here. Hanggang dito lang tayo sa noise, and then after that we will have a quiz. So we'll finish the quiz before 1 o'clock. 5 minutes lang yung quiz. Okay. So if you're going to look at this, what we call instrumental noise, there are 4 types of them. So the first one that we have there is the thermal, what we call noise, or yung tinatawag na Johnson noise. So if we have what we call this Johnson noise or thermal noise, this source of noise results, okay, in random voltage fluctuations produced by the thermal agitation of electrons as they pass through resistive elements in the electronics of an instrument. It's a thermal motion of electrons in a resistor. So if you're going to look at the formula that they have there, so the root mean square noise voltage, so yan yung movement ng electron, and then you have the K, that's the Boltzmann constant, and then the temperature, resistance, and then the frequency bandwidth of noise. Okay, so the relationship of this noise and the experimental, we could say, parameters, we could say is if we want to reduce the Johnson noise, we can do it by what? If we're going to look at the temperature, so paano natin i-reduce to? Paano marireduce tong ano dito with T? Do we need to increase the temperature or decrease the temperature? Anyone? Okay.
Decrease po.
Decrease. Kasi kapag dinicrease mo, bababa yun. So pag bumaba yun, mas mababa yung thermal noise. What else? Kita mo lang dito yan. Yung mga factor na yan eh. Baguhin mo yan. That results to low or smaller what we call value here. That's one ways to reduce this type of noise. Maybe this one. The frequency. Okay, you can decrease the frequency bandwidth of the signal. Ano pa? Pwede ito. If you decrease the resistance, they will also decrease. Okay? So, yan yung ways na mami-minimize mo yung thermal noise. You can find it in instrumental equipment. And then we also have the so-called shot noise. So when we're talking about shot noise at the thermal noise, usually it involves what? Electrons, di ba? How is this different from the thermal noise? Okay, you don't include the temperature here. Look at the given here. You have the I, which is what? The current, and then the charge of the electron, and then the frequency bandwidth. Okay, shot noise is the movement of electrons across what we call a junction. Okay, so when you have this what we call shot noise, it's just like there's a collection of random quantized events. Okay, because shot noise, this type of noise results in current fluctuation. So see the difference? This is current fluctuation and the other one is what? Instrumental voltage fluctuation. So bakit nagkakaroon ng current fluctuations dito sa shot noise? Okay? It is produced when electron pass through a junction in a random motion, which highlights the quantized nature of the electron flow. Okay? So if you're going to look at the relationship there of this shot noise with the experimental parameters, so you just look at that one, the current. Okay? The electron or electronic charge and the frequency bandwidth. Okay? And the best way they said to minimize this or to reduce shot noise is yung decreasing this frequency bandwidth. You just reduce that one. That's the best thing. So I hope you can differentiate the shot noise from the thermal noise. Current fluctuation and the other one is voltage fluctuation. And then we have this so-called flicker noise. So any noise that is inversely proportional to the signal 1 over f or 1 over frequency. Okay. If we have this flicker noise, 1 over f or 1 over frequency, it's because of the magnitude of this what we call flicker. Have you heard the word flicker? Ano yung flicker noise? What comes to your mind when you heard the word flicker?
Yung fluctuations po ng
Kapag may ilaw ba, pag nag-flicker, ano nangyayari dun sa ilaw?
nag-fluctuate po yung light po niya.
Okay? So it's hindi siya steady, di ba? Sometimes it vary usually in brightness. Parang magba-bright tapos mag-aano, yung parang didilim. Okay? So parang yun yung term na tinatawag natin flicker. Okay? So it is inversely proportional to what we call the signal. So 1 over what we call the frequency. So yung source ng tinatawag nating flicker noise is still uncertain, and it seems to be significantly only happening at low frequency. Significant at low frequency. Okay? So they said it is characterized on having a magnitude that is inversely proportional to the frequency of the signal that is being observed. Now, the last but not the least here, this one, environmental noise. So if you have an environmental noise, this is just a composite of different forms of noise that arise from the surrounding. And I have experience on that. I don't know if you believe me, but if you have an elevator and sometimes the electricity and elevator can give some fluctuation. That's the reason if you look at some of the lab, they have this so-called vibrating table. They don't want the table to be moving. Okay? That table is so heavy and expensive. So usually this is what? Compact table. Okay. So the experience that I have in my what we call lab, in my other lab, there is a train station near the school. So what happened? We're analyzing something and the Raman. So what we expect there, if there is change in the environment of the biomolecule that we are trying to analyze, that means there is a shift in the peak. So we're happy after 5 years, there's a 5-wave number shift. And then we realize that, oh, maybe it's caused by the subway train that passed through the school. So how do we determine that? We look at this standard, the toluene. So we saw that the toluene is also shifting. Okay. So we said, oh, this is part of this what we call noise. So any electrochemical device that gives off electromagnetic radiation, like cosmic rays, whenever we have a Raman, even though we work on the dark, from time to time we have a signal like that. And then in the next one, it's not anymore. So we can say that there's some cosmic rays that the instrument was able to absorb. Okay. And as I told you, instrument may pick up the signal. So that's the experience that I have. So you have this what we call noises. Okay. So how are you going to solve them? How are you going to solve this what we call noises? So if you're going to look at specific environmental noise, yung electrical power lines, electrical equipment, the cell phones, a drip in temperature or the aging of the electronic component, what we call component. So if you're going to look at this, what we call environmental noise, ito yun, no? So, kita niyo yung environmental noise. Year 1, temperature, tumaas yung signal. Okay? Day 1, yung temperature bumaba, may change of signal. Change of classes, may change of signal. Elevator, it has a change of signal. Power line, there's also what we call corresponding change in the signal. Okay? Now, if we want to improve the signal to noise ratio. So I'm showing you here some signal. So what's the difference of the first plot with the second plot? Saan mas accurate?
First plot po.
So this one. Okay? And if you have a signal to noise ratio like that, ito yung noise eh. You're good. But if your noise becomes 10 times compared to this one, it will affect your signal. Kita mo yan? So if you're going to look at the signal to noise ratio here, so maybe if I can assign value, this is around 52, this is around 26, and this is around 10. Okay. And if you're going to look at the peak-to-peak noise level, that's around what? 0.19, yung ano dito. Now, what happened if you make this 10 times? So this now become what? 1.9. And if you have that 1.9, ano mangyayari dito? Yung signal to noise. So you increase it by what we call 10. So your signal will decrease by 10. So increasing the peak-to-peak noise level ito, tenfold would result in the decrease of the signal to noise ratio by also a factor of 10. So kapag minultiply mo to by a factor, yung mga signal mo will be divided by the same factor. And as you could see here, you cannot distinguish your signal from the noise, especially this one. So how are you going to do that? How are you going to enhance the signal? So sabi nila, merong two ways. Isa yung hardware, which they call is just analog based. Analog filtering, okay? And some of the device that they have here, hindi ko na siya anuhin isa, okay? Yung grounding and shielding. So usually they use what? The Faraday cage to prevent some fluctuation. They also use the so-called RC filtering. Resistant capacitor filter. It's an analog filtering. And sometimes they do modulation, wherein they convert the direct current signal to high frequency, what we call alternate current, and then they modulate. Okay. One thing that they do in the IR, they have this rotating wheel for the what we call signal chopping. And also to amplify the signal, okay, they have this so-called lock-in amplifier. So this is what the analog filtering do, RC filtering. So you have a noise here. So if you put an RC filter, okay, resistance and the what we call capacitor. So what happened there? If you pass it through an RC filter, your data become much better. Here you can see the noise is not as high as the one that you can see here. Now, if you try to modulate it, okay, So we could say this is what your original signal. So what do you see here? Okay. You just see that this one. But if you do some modulation and then you modulate them, okay, there's some sort of what we call a demodulated signal. Yung sa chopping, when we go to the IR, okay, what it do ito lang yun, rotating wheel. So light, tapos i-block yung light and then light again. So pag nag-ikot siya, so in doing that, nami-minimize niya yung signal. So, nami-minimize niya yung noise galing doon sa sample. At yung pumupunta lang doon sa transducer ay yung signal ng sample. Now, if you have a chopper amplifier, okay, what it do is sometimes it lock in here. So if you have this signal, so kapag what we call yung amplifier na yung magti-device dito, to the point that it's going to increase. So from 6 millivolts, magiging 6 volts. And then, maano mo yung baseline. So makikita mo na ngayon, okay, yung signal mo separated from your noise. Now, another thing that we can do is software methods. And this is the easy one. Usually this is what? The digital filtering. Ensemble averaging is just what? Pag nag-ensemble averaging ka, you just collect more and more data. That's what we do in Raman. So we just have to what we call collect as many samples as it is. But there's a limit, especially if you have what? Biological species or biological material. Pwedeng masunog yung sample mo because a laser can just be what? Can generate a lot of power. But if you're going to collect them, what happened is, here, as you could see, this one. You don't know if it's a true signal or it's noise. Sampa, ito. Okay? But if you're going to collect them and maybe average them, you will find out that this is the signal that you will have. Pag bago ka, mahirap tingnan, but if you working with the type of instrument and you have seen most of the spectra, you will see right away, oh, this is true. Okay? And then we have this, what we call boxcar averaging. So titingnan mo dito yan. Oh, parang point by point. Tinitingnan mo yung difference. Okay? Yung different, what we call spectrum mo. If you have this, what we call boxcar, ano ba yung notes ko? May notes ako sa boxcar. So sa boxcar averaging, the average adjacent data points in a single scan. So the sampling rate must be sufficiently high to minimize distortion of your analytical signal. Okay? So doon tayo magtatapos ngayon. On Friday, we're going to do calculation. So mag-ano kayo ng calculator on Friday. And then meron akong ibibigay na one problem sa discussion. Tapos isasubmit nyo by Saturday. Yan yung parang problem set natin. So question before I open the quiz. The quiz is just 5 minutes. I think 4 questions. So how many of you are here? 28. So tatlo ang nawawala. So I'm trying to open it now. So isi-set ko ang due 1 o'clock. Kita nyo?
Kita na po.
Take it now. It's just for question in 5 minutes. I'll turn off the recording now.